So this is the fourth in a series of videos on this E&L terminal, the VTE-1. It stands for Video Terminal Electronics, according to the subscreen down here. So VTE is Video Terminal Electronics. We have, in a previous video, we've unboxed the unit. We opened it up. We took the case off and we looked at the printed circuit board and the chips, etc. here, a bit of the schematic. In the third video, we rewired this transformer for 110 volt operation. We converted it from 230 to 110. The unit originally had this line cord on it. It came from Australia. Of course, this is not a good line cord for US operation. I have temporarily taken that line cord and I've just patched in an IEC connector. I will do this correctly at some point going forward. I'm still debating whether to buy an AC out, or a male AC plug, and just hook up, with screw terminals to mount this in, or just replace the entire cord. Boy, you can't talk here. So, really at this point, I want to do a gross DC voltage check. Now, I do know the unit was working when it was shipped. On eBay, there was photos of the unit working with a monitor hooked up and characters typed. So it should still be working. It arrived here nice and clean. There was no issues. I don't think I can get that sticker off. It's been on there so long, but I'd like that 230 volt sticker off. Well, we don't need to do this on camera here. I don't know why I chose right now to do this, but I did. Anyhow, let's look at DC voltages. So we've got a 16 volt filter cap and two 35 volt filter caps. And my assumption is that because the 7805 regulator is sitting right here, plus 5 VR1, and this is a 16 volt, that this is the filter cap for the plus 5 volts. And these two are going to be filter caps for plus 12 and minus 12. We looked earlier in the schematic, there's three taps on the transformer, there's three outputs on the transformer, they're each independent. One of them powers through the large bridge rectifier to the plus 5. The other two power to plus 12 volt regulators. These are both plus 12 volt, but because they're completely isolated, the outputs here, you can basically take the positive 12 output, hook it to the ground reference, and get a negative 12 rail out of it. Like I said, we discussed that briefly in a previous video. So this ground here on this 16 volt cap should be a good common system ground. So I should be able to go to each one of the positives on the capacitors and look at the raw voltage, and I should be able to go to the output, which I believe is going to be this pin on this side, the input. Yeah, I believe this is the output, and we should be able to measure 12 volts, and 5 volts. So I've got what I believe is the unit power off. I'm going to turn on the IEC cord. Oh, Anna's going to join us. And I'm going to, so I did see the voltage come up, we see it rolling off. So power did come on. We're seeing 12.1 volts across this cap, and that's getting regulated down to, it should be plus 5, 4.98. So nothing wrong with that. The only thing I could say is wrong with that is there's 12.1 volts here coming down to 5 volts, so that's a 7.1 volt drop. That's going to create a lot of heat in the regulator at higher currents. We should see something positive here above 12. I was estimating 18. Okay, 25. Oh no, I was estimating 25 here. It's an 18 volt tap on the transformer. RMS 18 times about 1.4. It's going to be 18 plus 9 minus a couple volts is about 25. But anyhow, we've got 24 volts here, 25 volts, and it should be being regulated down to plus 12 here. Okay, it's going to be regulated down then to minus 12 right here. Well, that's the 25 in. Yeah, that would be the input. Is this pin going to be the output? No. Did I just not? There, I just didn't get a good connection to the oxide. So we've got plus 12 there. We should see about 25 volts here as well. confused why we're seeing 12 thing. I need to be careful around this transformer over here. Okay, that's curious. Actually, I'm going to power off and I'm going to change my ground reference. Well, no. Let's power it back up. We should be seeing negative 12 here. And we do. So that's negative 12 with reference to the system ground. So what's actually happening is the 12 volt output of this regulator is tied to the system ground. It would be tied over here, and then the ground pin becomes a negative pin in that case, and that plus 12 gets converted to a negative 12 regulator. And it's negative 12.1 volts. This was positive about 12.1, I believe, 12.0, plus 5. We should have a minus 9 either here, minus 5, or is it minus 5? What we got over here? There's the minus 12 coming in. Is it negative 5 that the 1702 uses? I was thinking it was, no, it's negative 9. Oh, that's the drop. Wow, I am just completely brain farting here on what that voltage should be. It should be negative 9. That's the UART. That's the decoder. Yeah, it's a 9.1 volt Zener that should be giving us negative 9 volts on pins 16 and 24 of the 27 or 1702 up here. So we're looking at the schematic section right here. Minus 12 is coming in. We saw that on the resistor, but it should be minus 9 out if that's the correct. Oh, interesting. So is that not? Oh, I'll bet. Okay, that is CR8, I think, R32. R32, okay. So I see what's going on. This Zener and this resistor are not the minus 9 volt supply. They are creating a minus 5 volt supply that I'm sure is used by something on here. So this resistor right here is the dropper resistor, the 47 ohm, and it's 47 ohm, and actually agrees with the schematic, and it's half watt based on the size. And there's a diode over here that is CR9, which is this diode, and that's where I should find the minus 9 volts. So, okay, I'm happier with that. Do the 27, well, the 2708s require minus 5, I think. We'll look at the schematic in a minute. Let's get over here now and see if we find minus 9. That's where I expected to find it, and it's there. And if I very carefully get on pin 24 here, we'll see the minus 9 there, minus 8.7. You know, it's close enough. It's minus 8.8 is where it's at. So it's really close enough. Okay, that helps. I now know there's 2 negative voltage regulators in the system, both Zener based. And you know, in an earlier video I mistook that 100 ohm for the 47 ohm called out here and wondered why it didn't match, so I had that wrong. You know, this is why we do this kind of work, why we kind of work through everything systematically. Let's see, there is the character generator ROM, and it's plus 12 and plus 5 for the 2708. There is no negative. Oh, there is a negative rail. Pin 21 is at negative 5. Okay. So we see this here in the schematic. There's that 100 ohm resistor, the large one there, the 5.1 volt Zener sitting next to it, and it produces a negative 5.1 volt supply, which goes to pin 21. So we understand what both of those Zeners are for. So, you know, power supplies from just a DC measurement perspective look fine. We can see the logic probe over here. Both LEDs are lit. The input is floating, so who knows What it is there isn't saying. I'm not going to play with that here. I was able to determine that these wire loops actually connect the voltage regulator outputs to the main system. So I think the red's the +5. No, that's wiring loom. There was 3 of these, I thought. But basically they connect the power from these regulators to the system board. I guess you could power it a separate way if you wanted to. Now the problem with regulators like this is if one of these regulators short, if this guy was to short input to output, it would pass full 12.2 volts to the logic, and it would fry the logic. And with the 25 volts on here getting out to the plus and minus 12, it would just fry it. Take the power off. Does that switch actually light up? It does, only it's really dull. There's a neon bulb, it looks like, in the main power switch for the unit. It's just really dull. So let's get this out of the way. Anything else to talk about here? I guess there's one more thing while it's on my mind. Actually, I'm going to turn the power off over here and save all of this because I'm going to be moving it around and I don't want to get shocked. There's, in this case, 120 volts exposed over here, although we're now isolated. This switch on the back that we looked at, I think, in the second video is local or online mode. Switch to local, it's taking the TTL serial out and TTL serial in on the UART and just connecting them together. In line mode, it's taking in line mode, it's switching that input and output through the RS-232 line drivers to the terminals over here, and then somebody's wired in loopback wires here to actually create a loopback. So you could do a loopback either way with the switch or on the back. I think there's a schematic error. I'm used to using 1488 and 1489s as serial line drivers. The opto isolator is probably on the 20 milliamp current loop, honestly. I guess we can look at and question some of this while we're here. This is the serial interface schematic, amongst other things. And let's see what we see here. So there's a RS-232N, the common. I show both of these as just ground, so it's interesting they're separated for RS-232, but they are. It's labeled 1488 here and here both, and one of those has to be, or does that say 14, or maybe 1458? I don't know what a 1458 is. I was assuming it was a 1488, 1489 pair, but it's really not. So some kind of op amp anyhow is doing the level translation. The 20 milliamp current loop out is opto isolated. So there's that little opto isolator. The 20 milliamp current loop in basically drives a transistor that gets down through the serial in. You can see here the local line switch that either just does local echo back on. We got serial out here, TTL level serial out through the switch, back around to TTL level serial in, or translated, RS-232 levels out here, converted back to TTL and TTL driving. So no real surprises there. Apologies again for the noise behind me. That is a washing machine. I'm sorry you have to hear it. It's Sunday here. I have to do laundry. It's next to the lab. It just happens. Again, apologies. Anything else to look at in this video? I really think the next video is going to be get the keyboard hooked up and hook up a monitor and see what we see. So I think that's probably what we'll do in the next video. I really don't want, I want to keep those. Little paper tags, I don't want to lose them just because it's original that way, although the 220 I'm going to scrape off. Anyhow, I will see you in a future video.